Today I'll solve the 20-second challenge on Ethernaut called DEX. The goal of this demo is for you to hack the basic DEX contract. You start with 10 tokens of token 1 and token 2. The DEX contract starts with hundreds of each token. You will be successful if you manage to drain all of token 1 or token 2 from the DEX contract. I'll copy this code over to my code editor and also deploy this challenge. I've copied the code from Ethernaut over to my code editor. Let's go over the goal of this challenge again. We start with 10 token 1 and token 2. The DEX has 100 tokens each, and the goal is to drain all of token 1 or token 2 from the DEX. So scroll down, let's take a look at the DEX contract. First, I noticed that it has a modifier called only owners, so I assume that we won't be able to call these functions. Scroll down. Get swap price function and balance of are read-only functions, and we have a function called approved, and we also have a function called swap. The swap function does some basic checks and calls the function get swap price and then performs the actual swap. The way the amount of tokens that come out of this swap is calculated is by calling the function get swap price. So let's take a look at this function get swap price. The way that this function calculates the amount of tokens that is going to go out is it multiplies the amount that came in by the amount of tokens that's going to go out and then divide by the amount of tokens that we're selling. We know that this DEX starts with 100 tokens of token 1 and token 2, and notice that it is also doing a division, so we might be able to do some rounding error and be able to drain the tokens from this contract. For example, let's say that we put 10 of token 1 and the DEX has 100 tokens each, and once you do the math, you'll get 10 of token 2 out. Once we have 10 token 2, at this point, the DEX will have 90 token 2 and 110 token 1. So we can do a swap from token 2 to token 1, put in 10 token 2, and get out 24 token 1 out. Notice that just by doing a swap from token 1 to token 2, and then doing a swap from token 2 to token 1, we get more token 1 than what we started with. We can repeat this process several times, swapping from token 1 to token 2, and then from token 2 to token 1. At every step, we will get more tokens from the trade. By repeating this process, we'll be able to drain the DEX. And to get the token balance to be completely equal to 0, we'll have to do some math. For the last swap, we'll need to do some math to calculate the amount of tokens that go in so that the balance of the other token will be exactly 0. One swap before the last swap, these are the balances of tokens. Token 1 is 69, and token 2 is 110. So for the last swap, we will be putting in some amount of token 2 and then try to drain token 1 to be 0. And we can calculate the exact amount of tokens 2 to put in to get the balance of token 1 to 0 by putting in the numbers into this equation. So what we're solving for is the amount of token 2 to put in. So token 2 amount in times 2 will be token 1. So this will be balance of token 1. Divided by from will be token 2, so this will be balance of token 2. Putting in numbers into this equation will give us the amount of tokens that will come out. Earlier I made a mistake. The amount of token 1 inside this contract after this last trade will be 69 plus 41 in. So this will be 110 token 1s. From 110 token 2, 65 went out. So now the current amount of token 2 inside the DEX will be 45. And for the last step, we are going to put in some amount of token 2 and try to bring the balance of token 1, which is 110, to 0. The amount of token 1 that must come out from this trade, we'll say 110, and that is the equation that we'll need to solve. So let's plug in some number into this part of the equation. 110 is equal to token 2 amount in. That is the variable that we don't know. So I'll just say token 2 amount in times what is the balance of token 1? The balance of token 1 is 110. Divided by what is the balance of token 2? Balance of token 2 is 45. So solving for this equation, solving for token 2 amount in, we get 110 divided by 110 times 45. I'm just dividing both sides of the equation by 110 and then multiplying by 45. We get token 2 amount in. Let's simplify the left side of this equation. 110 divided by 110, that is equal to 1, times 45 is simply equal to 45. So this is 45 is equal to the token 2 amount in. Okay, we're now ready to write our hack contract. What we're going to do is do a swap multiple times, and for the last step, we'll put in 45 token of token 2. This would bring the token 1 balance of the DEX to 0. So I'll cut this and then paste it up at top, and then we'll write our hack contract. Contract hack. Notice that the DEX contract is using the OpenZeppelin contracts, but we're going to be using Remix to deploy the contract, so I'm going to declare some interface and then just copy and paste the code above the import. So the interfaces that we're going to need is the DEX contract, token 1, token 2, get swap price, and the function swap. And we're also going to need an IERC20 interface. With that, we'll declare some state variables. So I'll say I DEX private immutable, I'll name it DEX, and IERC20 private immutable token 1 and token 2. Next, we'll initialize these inside a constructor. Constructor IDEX underscore DEX. We'll set the DEX equal to the DEX from the input, and then we'll set token 1 and token 2. Token 1 equal to IERC20 of DEX dot token 1, and token 2 is IERC20 DEX dot token 2. So next, we'll write a function, pwn. This will be the function that we're going to execute to drain the token from the DEX. This will be external. First, what we're going to do is transfer token 1 and token 2 from message.sender. So that will be from our account. Token 1 dot transfer from message.sender to address. This, we start off with 10 tokens, so 10. And then do the same for token 2. Next, we'll need to approve the DEX to spend from this contract. So say token 1, approve address of DEX. Since we're going to be doing multiple swaps, this will not be 10 tokens. I'll just set it to the max uint. So say type uint.max. And then the same for token 2. Next, we're going to be calling the function to do multiple swaps. So this is what I'm referring to. We're going to do some multiple swaps, and eventually we'll drain the amount of tokens inside the DEX to 0. So first, I'll create a helper function swap, and then say IERC20 token in, IERC20 token out. This will be a private function, and what this function will do is perform a swap by calling the DEX. DEX.swap address of token in, address of token out for the amount all of token in. Token in dot balance of address this. That completes the internal function to do a swap. It's basically going to swap all of the token in inside this contract. So next we'll need to perform the swaps. So how many times do we need to do? Once, twice, 3 times, 4 times, 5 times, and then there's 1 for the last time. So in total 6. So first I'll do the swaps. Say underscore swap token 1 for token 2. That's once. Next we'll do a swap from token 2 to token 1. So that's 2 times. We'll repeat this again. That's 4 times. And then on the 5th time we'll do from token 1 to token 2. And then for the last swap, we'll need to swap 45 token 2, and then we should get back 110 token 1. So say dex.swap address of token 2 for address of token 1 for the amount 45. And then lastly, we'll check that the balance of token 1 inside the DEX is equal to 0. Require token 1 dot balance of address DEX, it should be equal to 0. Otherwise, DEX balance not equal to 0. Okay, that completes our hack contract. So I'm gonna copy the interface and our hack contract over to Remix. Paste the code inside Remix, hit Ctrl S to see if the contract compiles, and the contract compiles. Next, I'm gonna go get the address of the DEX from Ethernaut. Inside Ethernaut, I'm gonna type F12 to open the browser console, and then get the contract address. Copy this. I'll paste this inside Remix, and then we're now ready to deploy the hack contract. Click on the deployment tab, make sure that we're connected to Goerli testnet, make sure that we selected the hack contract, copy the address of the DEX, and then deploy the hack contract. Okay, we successfully deployed the hack contract. Now before we call the function pwn, we'll need to approve the hack contract to spend our tokens. So to do that, we'll need to get the address of token 1 and token 2. And to do that, I'll select the IDEX, and we're gonna load this interface to get the address of token 1 and token 2. Copy the address of DEX, paste it here, load the DEX interface at the address of the DEX, scroll down, open the DEX interface, click on token 1 and token 2. And then I'll copy the address over here. So that's token 1 and address of token 2. So the next step, we'll need to approve the hack contract to spend from token 1 and token 2. We'll select IERC20, we'll load token 1, and then also load token 2. Scroll down. I'll first open token 1, and then we'll need to approve the hack contract for the amount something greater than 10. Let's just put 100. Okay, once the transaction is successful, we'll repeat the process for token 2. Open token 2, and then we'll need to call the function approve, copy the address of the hack contract, paste the address of the hack contract here, and the amount should be something greater than or equal to 10. I'll just put 100 again, and then transact. Once we give an approval for the hack contract to spend our tokens, we're now ready to call the function pwn on the hack contract. And the transaction was successful. The last step of this challenge is to submit our instance. Once you beat the challenge, you'll see the button change to go to next level.